Okay, notes today. Good news. If you can do what we were doing yesterday, then you're good to go today. Because today we're still, nope, up here. Today we're still talking about GCFs, but today we are going to be factoring out a GCF. So it's going to look and feel almost exactly the same as what we have been doing. There's just one small sort of thing we mix up. So what is a GCF? What did we say a GCF was yesterday?
Greatest common factor.
Greatest common factor. What does a greatest common factor mean? Okay, the biggest number that can be divided evenly into all the numbers. Okay. What did we say yesterday that a factor was? So when we were prime factoring, right, we were talking about factors. What did we say a factor was? Go ahead, Tyler.
Oh wait, is it what's the number to be multiplied?
Right, when we multiply the numbers together, it gives us the original number that we had. So today we're going to be looking for an answer where we're multiplying some things together to get the original problem that we had. But what we're multiplying by is going to be the largest number that goes into each of them. Okay. So let's say we have something like 21x to the third. Okay, but today instead of saying and then giving another number, okay, I'm going to put like an operation in here and turn it into a polynomial. So maybe if we have 21x to the third plus 14x squared.
That's good.
It's fantastic, right? Just think, you get to leave when the class period's over. I've been stuck here with it all day. Like literally this morning I just screamed. I was like, I can't even do this.
I thought shit, you don't yell.
I didn't yell. 21 and 14. What will go into 21 and 14? 7. So just like yesterday, we're going to divide out what goes into each of them. Hang on. Yeah, so do they both have the variable? Yes, the smaller exponent is? 2. I think there might be a pattern that this squeaking noise only happens like every other time. I just haven't quite figured it out yet. Okay, so then just like yesterday, we're also going to divide it out. Okay, so 21 divided by 7 is 3. We subtract the exponents, right? 3 minus 2 is 1, so we get the x. Now instead of writing down the word and, we're just going to bring down the operation. Okay, 14 divided by 7 is 2. We subtract exponents, which is 0. They cancel out, so there's nothing to write there. So now we're going to ask ourselves again, anything that goes into 3 that also goes into 2? 1, right? Nothing, 1. So we know we're done. But now we don't want to find the GCF, right? We're factoring out the GCF. So what is our GCF? 7x squared. Okay, which means we want numbers multiplied together. So just show multiplication with a polynomial when it's 2 terms, right? Multiplication is parentheses. And we're going to put our GCF out in front. So we'll have an answer of 7x squared times 3x plus 2. This is the same idea as if you were to prime factor 10. What does 10 split into?
2 and 5.
2 and 5. So we could say that 10 is the same thing as 2 times 5. Okay, this says 21x to the third plus 14x squared is the same thing as this times this. Now, we should also be sitting there probably going, wait a minute, this looks really familiar. what does this look like?
What's it called?
Right, the last trimester polynomials, where we would distribute. And if we were to distribute, we would get 21x to the third plus 14x squared. All we're doing is everything we did last trimester with polynomials backwards. Okay, we're just undoing that process with multiplication and polynomials from last try. Questions on this one? Okay, let's look at another one. Sometimes the GCF won't jump out at us as easily, which is okay because we know how to work through it. So what can we think of that will divide evenly into each of these? 2? Right, you could have picked something else. Do they all have the variable? Yep, smallest exponent. Okay, so we'll get a 12 x to the fourth minus 36x squared (48) no x. Okay, then we'll check again. How about 12, 36, and 48?
8.
12, 8, well, you can pick options here. 12 works. As long as we did the variable correctly to start with, we're good. 12 divided by 12 is 1. Do I need to write this 1 down here?
No. Yes.
You know, you could. You don't have to. Don't do it on purpose, please. 36 divided by 12 is 3. (48) divided by 12 is 4. Anything go into 1, 3, and 4? No, so what's our GCF? Right, we multiply 24x to the third. And we're going to put that out in front and wrap the rest that was left over in parentheses. Okay, so do you see how we're doing exactly what we were doing before? We're just sort of adding this parentheses and putting the GCF out in front today.
I think it is any other time.
One more and then we're done with notes. Oh, I don't think we've ever had a noise and then a squeak and then a noise. That was a new one. 12x to the fifth y to the third minus 6x to the third y squared. Okay, so what goes into 12? That will also go into 6. 6, 2, 3, whatever. See 6, heard 6. Do they both have the x?
Yes.
Yes. Smaller exponent on the x? 3. Do they both have the y? Yes. Smaller exponent on the y? 2. Okay, so let's divide this out. 12 divided by 6 is 2. We subtract exponents, that's a 2. That's a 1. here we have to be really careful. 6 divided by 6 is 1. Okay, and before I said, do we have to write that down? And we said no. And the reason why we said no was because we still had variables after it. Okay, but here when we look at our variables, those cancel out, and those cancel out. You have to put something here. It can't be 0, it can't be nothing. Right? 6 divided by 6 is 1. Right? X to the 0 power is 1. So if all of it divides out, you're filling it in with a 1. Then we can say we're done and put our GCF out in front. So as long as we were understanding how to factor out or how to find a GCF, factoring out a GCF really isn't much new info today. Any questions? And that's all we're going to look at with notes today.